Think about your morning routine. You wake up, the sun rises, you go to work, and by the time you head to bed, the stars are out. On Earth, this cycle takes 24 hours. Now, imagine a world where you could finish an entire 225-day trip around the sun and still not have seen a single sunset. You click because you want to understand the mechanical glitch that makes Venus the most rebellious planet in our solar system. Sounds like science fiction. In fact, this is the brutal reality of planetary rotation. A day on Venus lasts longer than its entire year. The central paradox is that while Venus is our twin in size, its clock is completely broken. Where are you watching from today? Let's warp time. To understand this temporal nightmare, we have to look at the orbital dynamics of the second planet. NASA's Magellan mission and the recent Akatsuki probe have provided the precise measurements we need to map this anomaly. On Earth, we have two ways to measure a day, but for Venus, these numbers are world-shattering. The first major mechanism is the sidereal day. This is the time it takes for a planet to spin exactly once on its axis relative to the stars. NASA data confirms that Venus takes 243 Earth days to complete one single rotation. However, Venus's year, the time it takes to orbit the Sun, is only 225 Earth days. Consequently, Venus has already finished its birthday before it has finished its first morning. If you were standing on the surface, the calendar would move faster than the clock. This makes Venus the only planet in the solar system where the year is shorter than the sidereal day. But there is a second twist. Venus doesn't just spin slowly, it spins backward. While every other planet, except Uranus, spins counterclockwise, Venus has retrograde rotation. If you could see through the thick clouds, the sun would rise in the west and set in the east. The second best point to establish here is the solar day. Because the planet is spinning backward while it moves forward in its orbit, the time between one sunrise and the next is actually shorter than the sidereal spin. On Venus, a solar day lasts about 117 Earth days. This means that even though the planet takes 243 days to spin once, you would see two sunrises every year. The cumulative math of this slow-motion spin is the first domino in the planet's hostile environment. Without a fast rotation, Venus cannot generate a strong magnetic field like Earth. That realization would be enough to classify Venus as a failed twin. But what happened next made the slow spin look like a minor detail. We realized the atmosphere is so thick it might actually be the thing pushing the planet backward. As we move from the spin to the atmospheric torque, the tension moves from how it moves to why it moves. Wait, before we calculate the crushing weight of the Venusian air, if you're finding this planetary physics fascinating, hit subscribe. We're decoding the cold reality of the cosmos every week. The third major mechanism is atmospheric tides. NASA's Pioneer Venus project revealed that the atmosphere of Venus is nearly 93 times heavier than Earth's. It is essentially a supercritical fluid of carbon dioxide that acts more like an ocean than a gas. This leads to the theory of atmospheric drag. Some NASA researchers believe that billions of years ago, Venus might have spun faster and in the correct direction. However, the sun's heat created massive tides in that heavy atmosphere. Like a brake pad rubbing against a wheel, the friction between the thick air and the rocky surface may have slowed the planet down over eons, eventually stopping it and lurching it into a slow, backward crawl. While the planet's surface is barely moving, the clouds are simultaneously mounting a massive rebellion. This is called superrotation. While the ground takes 243 days to rotate, the top layers of the sulfuric acid clouds whip around the planet in just 4 Earth days. The winds reach speeds of 224 miles per hour. This creates an escalating severity. The atmosphere is essentially a runaway engine. This superrotation helps distribute the sun's heat, creating the most powerful greenhouse effect in the solar system. The surface temperature stays at a constant, lead-melting 900 degrees Fahrenheit 480 degrees Celsius, whether it is day or night. The real drama lies not in the heat, but in the crushing pressure. Standing on the surface of Venus would feel like being 3,000 feet underwater on Earth. Focus is your greatest weapon. That decision by the planet to spin slowly means there is no cool side of the planet to hide on. But what happened next made the twin comparison look like a cruel joke. We realized that Venus might be Earth's future. This is the peak of the truth, the runaway greenhouse. This is the highest informational value I can give you. Venus is a warning, not just a neighbor. NASA's climate models suggest that billions of years ago, Venus may have had liquid water oceans and a climate very similar to Earth's. The climax occurs when you realize that the sun's increasing brightness caused those oceans to evaporate. Water vapor is a potent greenhouse gas. As the oceans turned to steam, they trapped more heat, which evaporated more water. The highest informational value lies in the loss of the carbon cycle. On Earth, plate tectonics and oceans help trap carbon in rocks. On Venus, without water to lubricate the plates, tectonics stopped. The carbon dioxide from volcanoes stayed in the air, building up until it created the Hell's Cape we see today. The reality of 2026 is that in-situ exploration is 80% of how we plan to solve this. In May 2026, NASA is moving forward with the Da Vinci and Veritas missions. Da Vinci will actually drop a probe through the atmosphere, measuring the chemicals in those clouds in real time. We are looking for the chemical fingerprints of that ancient ocean. We aren't just curious about the long days, we are looking for the moment the planet broke. It proves we have created a flow that has value because it is a cautionary version of a hidden truth. But there is a silent trap waiting at the end of this success. Everything I just showed you about the 117-day solar day is useless unless you understand the one thing I didn't mention at the start. Most people think the day is the only thing that's long. That decision to ignore the night would have been enough to miss the point. But what happened next made everything before it look minor. We have traveled from the 243-day sidereal spin to the 117-day solar day and the crushing weight of the 900 degrees Fahrenheit atmosphere. The resolution here is understanding that Venus is a planet where time and space have conspired to create a perfect prism. You now have the roadmap to the Venusian anomaly. You know why the year is shorter than the spin. You know why the atmosphere acts as a brake on the planet's rotation. You know why the superrotation of the clouds is the only fast thing on the planet. The expert status only comes after the very active work of realizing that habitability is a fragile balance of spin, distance, and air. Bring your expectations down to earth. Focus on the fact that our 24-hour day is a gift of physics, so your wonder can actually take flight. But there is one thing I did not mention at the start of this video regarding life in the clouds. In 2026, the debate over phosphine in the Venusian atmosphere continues. Some NASA-funded studies suggest that about 30 miles up, the pressure and temperature are actually very similar to Earth. There is a Goldilocks zone in the acid clouds where microbial life might be floating, living through those 117-day sunrises. Navigating the transition from amazed spectator to planetary thinker is the hardest part of the journey. It requires you to stop being wowed by the weird clock and start being awed by the complexity. If you can master this perspective, you won't just see a weird planet, you'll see a complex machine that lost its cooling system. You have the data and the framework. Now you just need the discipline to keep looking up as Da Vinci prepares to touch the air of our twisted twin. Venus is not just a planet where time moved wrong. It is a planet that ran out of time to stay like us. A day on Venus is a nightmare, but the journey to get there is even more dangerous for the human body. Watch this video next. It shows you the exact NASA data on how microgravity and radiation dismantle an astronaut's health during long-term space travel. Click it now and I'll see you there.